Hey guys, welcome back searching for symmetries. Today we have a fun geometry problem from the IIT JEE Advanced 1997 exam. The problem is on the screen. As always, I request you to pause the video and try to solve the problem. Okay, so let's get into the problem. The problem says that let C be any circle with center 0, root 2. Prove that at most two rational points can be there on C. A rational point is a point both of whose coordinates, that is both the x and y coordinates, are rational numbers. Okay, so problems like these, students sometimes tend to get very befuddled. Like it seems so mind boggling, right? There are infinite points on the circle. How am I going to prove that there are at max two rational points? Should I test all of these points somehow and see whether they are rational or not? No, the answer to such questions is always proof by contradiction. That you assume what the problem says can't happen to be true, and then something breaks, right? That's the idea. So let's try and solve this problem. Okay, so we have a circle with center 0, root 2. Let's just draw a circle. There we go. This is the y-axis and this is the x-axis, right? This is the center. Let's call it C. C is 0, 2, and it says that there can be at most two rational points on C. So let's assume that there are three rational points. Let's say that point P, x1, y1, Q somewhere here, Q, sorry for this. Okay, here we go. Q, x2, y2. It doesn't matter where these points are. Let's just take 3 points, right? And R, x3, y3. Let us assume that P, Q, and R are rational points. What it means is that x1, y1, x2, y2, x3, y3 all are rational numbers. Okay, so what happens if there are three rational points? The most intuitive thing to do is to join these points and then see that PQR is a triangle, right? And what is PQR? PQR is a triangle whose circumcircle is the given circle C, right? Okay, this is circle C. Let C1 be the center, right? So circle C is the circumcircle of PQR. But we know what circumcircle is. The circumcircle is nothing but the point of intersection of the perpendicular bisectors. So let's just take QR. Okay, now we draw a perpendicular bisector, which is, so let M be the midpoint, and we draw a 90-degree line. This should pass through C, right? Because C is the this should pass through the C1, which is the center of the circle, which is given as 0, root 2, right? So now what is the slope of QR? Slope of QR is, let me write, slope of QR is y3 minus y2 by x3 minus x2. Now y2, y3, x2, x3 are all rational, so slope of QR is rational. So the slope of MC1, right, where C1 is the center, that is given to be 0, root 2. So MC1, eh, slope of MC1 is minus 1 by slope of QR. This is also rational because slope of QR is rational, right? Now, what is the point M? Point M is the midpoint, x2 plus x3 by 2, y2 plus y3 by 2. So M is also rational because x2, x3, y2, y3 are again rational. So the slope MC1 is rational, the point M is rational. So we have the equation of this line, that is y minus what is the y coordinate of the center, that is y minus root 2 is the slope into x minus 0, right? Slope of, I'm just denoting slope of MC1 as M, right? So this is the equation of the line, the perpendicular bisector, that is MC1 where C1 is the center, right? Now MC1 passes through M, so let's just take M as x4 y4, which is already given, which we already know as x2 plus x3 by 2 and y2 plus y3 by 2. So this line passes through M, so we have y4 minus root 2 is mx4, where x4 y4 is nothing but x2 plus x3 by 2 and y2 plus y3 by 2. I'm just giving it a short notation. So we have root 2 equals y4 minus mx4. Now the right hand side, y4 is nothing but y2 plus y3 by 2, and y2 and y3 are all rational numbers, so y4 is rational, the slope is rational, and x4 is rational. So the right hand side is rational and the left hand side, root 2, is, we know, an irrational number. So we have a contradiction. So our initial assumption that we have 3 points on this circle is false, because if we have 3 points, then we have a triangle. If we have a triangle, this circle is the circumcircle of the triangle, and the circumcenter of the triangle has an irrational point, which cannot happen if all 3 points of the triangle are rational points. So this is the proof, and this proves that that circle has at most 2 rational points, which can be there on C. So yeah, I hope you've enjoyed this problem, and please like the video if you have, and subscribe to my channel. I'll get you more challenging problems with elegant solutions very soon. Thank you.